If the top results are wrong, we'll tune BM25 with field boosting, so Elasticsearch ranks what users actually meant. By the end, you will know how to steer BM25 with simple field boosts, so the search results match intent, not just raw keyword overlap. I'm Professor Pine, teaching Search and IR with simple Python. Search goes wrong when the wrong field wins. A product title might be short and exact. A description might be long and noisy. BM25 gives a solid baseline relevance score, but it treats every field the same unless we tell it otherwise. Tuning field weights fixes that. We get more sensible top hits, fewer false positives, and a better experience for users searching short, intent-rich queries. The intuitive idea is to reward the signals that matter. If a user types a short phrase, a match in the title should matter more than the same words in the long body. If an exact phrase appears in the title, we want that result near the top. Boosting is simply telling BM25 to count matches in one field as more important. It is cheap to test and often moves the needle visibly. We will build a tiny local example. We will connect to Elasticsearch, index a handful of documents with title and body, run a baseline search, then add a title boost, then add a phrase boost to stabilize the ranking. The code is small and readable in Python, and the changes you make map directly to production tuning. Now we'll connect to the local cluster. This snippet connects to Elasticsearch locally and verifies the cluster is reachable. It creates a client pointed at the local host, then sends a basic ping or info call to check that the cluster responds. The key lines build the client, call the health or info method, and print a short status so you know the connection works. If the ping fails, you get an exception or a false response and you stop. Getting this check right first prevents wasted work when indexing or searching later. In practice, you will rerun this at the start of any script that touches the cluster. Next, we'll seed a tiny test corpus. This snippet seeds a tiny BM25 corpus in Elasticsearch for relevance testing. It creates an index mapping with a title field and a body field, and then indexes a small set of documents that show typical title and body differences. The main ideas are explicit. One field is short and concentrated, the other is longer and more descriptive. After indexing, the snippet waits for refresh so searches see the new documents, and then it prints confirmation that documents were added. Keeping the corpus tiny makes it easy to observe how boosting changes the top results without noise from a large corpus. Now we'll run a baseline BM25 search. This snippet runs a baseline multi-match BM25 search over title and body in Elasticsearch. It sends a multi-match query that searches the same user query across both fields using the default BM25 behavior, so you get a baseline ranking. The important lines specify the query text and the two target fields. The response shows which documents score highest when both fields are treated equally. This baseline helps you spot whether BM25 favors long, noisy matches or short, exact matches, and it gives a concrete reference to compare boosts against. Next, we'll boost the title field to prefer short, exact hits. This snippet boosts the title field in an Elasticsearch multi-match to shift top results. The change is subtle. The query now lists title with a higher weight than body, so a match in title contributes more to the BM25 score. The snippet highlights the boost value next to the field name, and then runs the same user query to show new rankings. Increasing the boost makes titles dominate the score. Lowering it returns you toward the baseline. Watching which documents climb and which drop teaches you how strong a boost you need for your data. Now we'll add a phrase boost to stabilize exact matches. This snippet adds a title phrase boost with an Elasticsearch bool query to stabilize rankings. It wraps the multi-match in a Boolean structure that includes an extra clause, a phrase match against the title with an explicit boost, so exact phrases in the title get an additional score bump. The snippet shows the composed query and the combined results, and it explains how the phrase clause is scored separately and summed with the BM25 field scores. Using a phrase boost helps when short queries should match exact titles, while still allowing fuzzy or partial matches from other clauses. To map this toy example into a real project, index your production documents with the same title and body distinction. Test boosting on a representative sample of queries, and run A/B style checks on top result precision. The local tests show direction, and the same boost values are a good starting point for staged experiments. Recap. Field boosting tells BM25 which signals matter more. Use it when short, intent-rich fields like title should outrank noisy long fields. Caveat: too large boosts can overfit. Validate on real queries. Next step. Tune BM25 parameters K1 and B on the same pipeline to see combined effects of term frequency behavior and your field boosts. If short, practical IR helps you, subscribe and watch the IR videos.